Hello guys, welcome to this series which is on machine learning fundamentals. We were discussing hierarchical clustering in the first part of this episode. That was just 10 to 12 minutes of video, which was the first part, introductory part of this very important topic, so that we can understand the advanced unsupervised machine learning algorithms and building, in fact, a background, a foundation for that. There are related concepts out of which some of those concepts have been introduced. Just, it was a very short, precise intro to those. I shall be starting from the same point where we left the first part of this episode 16, and we shall be taking those concepts in quite a detail so that we can comprehend them, and it will be easier for us to understand the machine learning algorithms that are falling in this category, which are yet to be decided. So let me just present in front of you this slide. Agglomerative clustering was the one which we were discussing. In fact, this is coming in this clustering algorithms, which is a topic of discussion for episode 16. So we had just thrown some light on this, but we shall be discussing these concepts in quite a detail in this part of the series and in this part of this episode specifically. Agglomerative clustering is a method where each data point starts as an individual cluster. So when we are talking about agglomerative clustering, it is a method where a data point, for example, is there. It will be starting as an individual cluster. That means a data point itself will be starting as a cluster. And then what will happen is, and the clusters are iteratively merged. That means other data points, they will be iteratively, continuously, on a repetitive basis, they'll be added as they are found that they are having similarity with this data point. So as we find that, this data point is having a similarity with, those points are having similarity with this data point, they are going to be a part of this cluster. They'll be merged into this cluster. So that is what is agglomerative clustering. So this is a method where each data point starts at an individual cluster, as an individual cluster. So every data point is starting as an individual cluster, and then it goes on merging. So those clusters, individual clusters, will be merging on the basis of what? Finding the similarity between other clusters which are there. They are merged on the basis of similarity. That is what is agglomerative clustering. So let us just see it in quite a little bit more detail. We can think of, for example, students in a classroom. So initially every student is alone. Step one is closest students from small groups. In fact, we were discussing this hierarchical clustering last week, last episode, first part of this episode. So agglomerative clustering is here, and this is having an example. So we can just take an example which we are in fact taking for several these machine learning algorithms and the concepts which are there. So we can think of students in a classroom. Every student is alone, for example. So definitely every student is a separate entity. So step one is closest students from small groups. So we can make groups, small groups of students who are close in characteristics. Small groups merge into bigger groups. So finally, there is one group. So small to big, it is a bottom-up approach. So when we are talking about agglomerative clustering, as we had discussed earlier as well, it is a there can be a bottom-up approach in this. There is a bottom-up approach. So small to big. And then a simple example is data study hours for students is 2, 3, 8, and 9. These are separate data study hours for 4 different students. And the steps of this one will be, first of all, 2 data points, 2 and 3. They merge into one cluster, which is a cluster A. 8 and 9, because these are having similarity. These data points are having similarity. They merge into one more cluster called cluster B. And then A and B can merge together. Final cluster can be a complete, you can have a final cluster as a complete data, which will be 2, 3, 8 and 9. So this is a bottom-up approach which we are having, and there is one divisive top-down clustering. This is one more kind of clustering which is there, which we discussed in fact in the first part of the episode itself. A formal definition for this is divisive clustering starts with one larger cluster. So it is a large cluster, one large cluster. We are starting with that, and recursively splits it into smaller clusters. So what happens in divisive clustering, it's a top down approach where you are having a bigger cluster, one big cluster, and then we are splitting that cluster into smaller clusters. So it starts the whole classroom. For example, you are starting with an entire classroom, and then you are dividing them in based on the similarities. So step one will be divide into two groups. For example, the same example, if we are taking that we are having students as 2, 3, 8, and 9, we are dividing them into two separate groups, 2, 3, and 8, 9, and then further we are splitting them 2, 3, 8, and 9. So if we just see, this is a top-down approach. We had seen the bottom-up approach before, which was in fact the agglomerative clustering, and now we are having divisive clustering, which is a top-down approach. So this approach is used less compared to this agglomerative, which we, in fact, this is having more implementation rather than the divisive one, because in machine learning algorithms we and applications, in fact, we are having a requirement where the agglomerative clustering will be in fact suitable, where we want to in fact assemble different data points and group them into one based on their characteristics. So agglomerative is one which is applied more, and then there might be some very rare implementation where we are having a divisive top-down clustering approach as well. So if you have to understand this visual understanding of this, you can just see agglomerative hierarchical clustering. You can just see exactly we are starting with that, and then what happens, it's in fact dividing into groups, smaller groups, and then if you just see in comparison to this, if we see this divisive hierarchical clustering, what happens there. So this is exactly visual representation of what we are having here. So divisive, we can just see they're becoming separate. So it's exactly here. And then agglomerative, they are becoming one group. So that is reflected here on the upper side of it. If you want to see it in a different aspect, so visual understanding of this in a different aspect, you can just see agglomerative. There are individual points, and then we are able to cluster them we're able to make a single cluster. In the same manner, we are having in divisive, we are having a single cluster, we are dividing them into individual clusters. So this is on the left hand side, we're having agglomerative clustering. It's a bottom up approach, and then a divisive clustering, which is top-down approach. So this is some very important concept which will be utilized in the algorithms that are falling in this category. So it's very important to understand, comprehend, and then remember what happens in agglomerative clustering and divisive clustering. And these are the visual understandings. If you just see data points, how the clusters are created, I can give you the interpretation of this all. In fact, I'm having that by the end of this particular part of this episode. So if we have to give a comparison of these two, we see features. We are talking about agglomerative approach is bottom up, the divisive approach is top down. Starts individual point, so it's a one big cluster where from divisive starts, and then it goes on dividing it. Processes merge, that is split, so there can be a implementation for that as well. Complexity is lower, divisive is having higher complexity. Usage is very common for agglomerative, divisive is rarely used. So that's what I was telling you already. Agglomerative is used in practice, but divisive is very rarely used. There can be some rare implementations. And this particular slide, probably we have used it a little bit in the earlier part of the episode as well, where cluster, linkage criteria, and dendrogram. We are going to discuss these linkage criteria and dendrogram in quite a detail. So first of all, what is linkage method? Linkage criteria, definition of linkage criteria is linkage criteria determines how distance between two clusters is calculated. How we can calculate distance between two clusters, that is what a linkage criteria will be telling. So if we have to understand what linkage criteria actually is doing, what is linkage doing, or the linkage method doing, so we have to just understand that linkage criteria is there to determine how distance between two clusters is, how we will be able to calculate distance between two clusters, and why we need to establish and calculate the distance between two clusters, why it is needed. When clusters have multiple points, which points do we measure between? Linkage answers this. So which points will be measured, the distance will be measured between which points, that is what linkage will be answering, and that's why this is important. Linkage is important. And there are in fact key linkage criteria. There are types. In fact, we had discussed a little bit of this in the previous part of the episode. Single linkage, and we are having word linkage. Single linkage is the definition of this is distance between clusters, minimum distance between any 2 points. So when two clusters are there, the minimum distance that is between 2 points, any 2 points of these two clusters, is a single linkage. So connect clusters based on the closest points that they are having. Cluster A is having 2, 3. Cluster B is having, for example, 8, 9. The distance is 3 minus 8, because the highest number from one cluster and the least number for another one. So 3 minus 8 is 5 minimum. So distance is 5. So distance between these clusters here is 5. Very simple to understand. Behavior of this is it forms chains. Sensitive to noise, definitely it will be having a line kind of a, so because we are establishing clusters based on a single linkage. There's a single link which is there, single linkage is there, 2 points which are close to each other, we are establishing a cluster, and we are merging that. So that will be establishing a line kind of a thing, which will be in fact sensitive to noise, and it forms a chain kind of a cluster. Then there is one which is a word linkage. A word linkage, what is the definition of a word linkage? Word linkage merges clusters that minimize the increase in within cluster variance. So those clusters which are, which don't have a single point, but they should be decreasing the overall variance. That means the difference which is there in a cluster. So it will be merging. So if your one cluster is merging with another cluster, if the variance which is there, which was there earlier, and that is now reduced, that variance is reduced, it will be going for the merger. So the intuition behind this is merger cluster that keep groups tight and compact. So definitely when you are having a better variance, when you are merging with another cluster, that means the group is tight and compact. Then the group which gets created, that is tight and compact. So the behavior is it forms chains. It is this. I don't think this particular this one is sensitive to noise, so there might be a mistake on this one. So this is not sensitive to that sensitive to noise, because this will be forming in fact a cluster, a tight cluster, compact cluster, which will be there for the word linkage. So this is here the example of this. Cluster A is 2, 3. It means the mean is 2.5, and the cluster B is 8 and 9. The mean is 8.5. Word checks, will merger increase spread a lot? If yes, avoid merging. So if it is increasing the variance, the merger is increasing the spread, then it will be avoiding. If it is compacting this this cluster, the resulting cluster which is there, if it is getting compacted and it is gelled up together, then it will be going for the merger. Otherwise it will avoid. Behavior is produces compact clusters, as I was telling you. I think the previous one which was there, this particular component of the slide, it is wrongly placed there. So this is the exact one. Product compact clusters, most commonly used. So this kind of linkage is most commonly used because it's producing compact clusters. Single versus the word, we can have a comparison of these two. I want to keep this particular video as well, to limit it this one, so that it is not, audience is not getting bored with this. Distance is one feature, which is minimum distance point for a single linkage. A single point, this one linkage, word linkage, it will be a variance based, so it will be calculating properly whether the resulting cluster is better compact, it is having that this one decrease in the variance, or it will be it will be variance based. Definitely shape, it's a chain like cluster, but in the word linkage will be having a compact cluster, as we already described. Noise sensitivity, yes, it's high, it's low in word linkage, as we have seen this already. The usages in single linkage, it's rare. In the word linkage, it's most common as far as the usage is concerned. Visual comparison of this, if you just see overall clustering now. So if you say hierarchical clustering, we have done some non-hierarchical clustering algorithms already, which were there. And in that one, I think k-means we have used. It was in fact with unsupervised learning, the concept of that. And then when we discussed unsupervised machine learning with the k-means algorithm, and in that we just discussed PCA as well. So as far as hierarchical clustering is concerned, there is agglomerative and then there is divisive. If you just go to agglomerative, you can just have single linkage, complete linkage, average linkage, and then centroid, median, and word, which is there. So definitely these clustering, this visual comparison which is given there, that it's clear now. And then visual comparison, one more which is there, single linkage dendrogram is there. You can just see single linkage dendrogram. And then there is a word linkage dendrogram. There is in fact a dendrogram in data space, two cluster solution is there given. And then dendrogram in data space. So in fact it is giving us in fact the examples of this. We'll be discussing about what the dendrogram also shows you, what is that and what it shows you. So if you just see example data set, students performance, student hours and attendance, so these are there. So these are forming two separate clusters. You can just see cluster students into meaningful groups based on their study effort and academic performance. In fact, these are, you can just see these are into two groups which are evident there. Python implementation of this, definitely I'll be showcasing you the Python implementation. You can just have a look on this. But this program which is there, it is not using any kind of algorithm as such for the time being. It's just creating these different these graphics, different visuals, so that you can visualize these differences: single linkage, complete linkage, average linkage, and then we will be going for the interpretation. So this code, all of this you can just see that is based on that. It's a simple Python. This one we are not using anything else in this one, but we are displaying it. So let me just show to you that while we are running this. So it should be giving us the result. Wait for a moment. Be getting it. I think we got one result from there. It's going to give us multiple. So this is first of all the dendrogram. So you can have a look at this. And in the meantime, I can just give you the interpretation of this as well. So I can just show you both of them, the dendrogram which was there, outputs generated. So what we see actually the output of this program is a dendrogram tree diagram, final cluster scatter plots for each linkage type, and animated video cluster merging process. So dendrogram shows how clusters are formed step by step. So what is a dendrogram actually? And so dendrogram is a graphical presentation which shows you how clusters are formed stepwise. So because now we are having different types, so definitely it will be giving you different animations how clusters are formed. So key elements are bottom individual data points, branches joining, clusters merging, height of merge. So interpretation is if 2 points merge at low height, they are very similar. If they are merging at high height, that means there's a difference in them. And most important insight is that vertical heights tells you how far the cluster. That means if it is vertically, So down, bottom to up, vertical differences are there. That means they are apart from each other. Key elements, how to choose number of clusters, draw a horizontal cut. So anyways, let me just show this dendrogram again to you. So let me go back to this, and I shall be displaying this. You can just see single linkage here, and then there are in fact these points. So vertical points are making a difference, and then this is a single linkage which is there. So that means one point of this particular cluster which is here, it is joining with one more point of this cluster. So this is a single linkage, right? Now we can have, this word linkage where we are just, checking first of all that whether, two clusters are, if we are merging them together, whether we are getting a decrease in variance or if there's an increase. So that is something which we are getting with this one. And then there are different, in fact, complete linkages there. So that is this one which you are having. Not a single point. So this is the complete linkage. In fact, we'll be having an interpretation of this as well, and this is an average linkage which is there. So if you go to the interpretations of this, what is this complete linkage and average linkage, you can just see there. So if you just see the interpretation of results which are there. So final cluster, in fact, these are the ones which I showed you already. If you just see, what it shows, it is giving, in fact, here the different elements which are there, and what is their difference. So if you just see, so example interpretation is that several small merges at bottom, one large jumps at the top, then data naturally forms a few strong clusters. So definitely we are having, if the separation of points are there, bottom and top, so definitely the clusters will be forming automatically. Scatter plot, what it show, each point one data instance, colors, cluster assignment. So this program which is there, when I'm closing the one which is this one, when I close this, we'll be having a display of one more. So we'll be getting one more display of this. So that is coming. So this is the one which is there. So it shall be displaying on your screen now. So this is the final cluster comparison across the criteria. So you can just see single linkage, points, complete linkage, and then word linkage and average linkage which is there. In fact, we'll be having maybe a little bit of a more detail on this, these comparisons which are there, because this interpretation is not complete here. There are few aspects of interpretation which are still remaining, and then we'll be taking, in fact, dendrogram. We have already, we know what dendrogram is. The dendrogram reveals the hierarchical structure of our student data set, showing how individual data points merge into clusters based on similarity in study hours and attendance patterns. So this is what this dendrogram is showing based on the similarity of the students. One scenario like that. And these are different criterias. But before taking this DB scan, that's not going to happen to in this particular part of the particular part of the episode. So we are going to take it in the third part of episode. All of these concepts which we have gone through here, there might be certain few of them which are remaining. I don't want to just go extend it to beyond 25 minutes. So I want to keep it lesser than that. So this particular video, it will be this particular episode, third part of that will be taking, in fact, little bit of understanding of you already know that what single linkage and a word linkage is. We have just taken it with an example. I'll be talking about what are these representations which are given, that average linkage and complete linkage, and these will be very useful in understanding then the machine learning algorithms that are based on that. So thank you so much once again for joining. Please provide us your valuable feedback so that we can improve. And these concepts which are there, I consider myself a student of computer science, computer engineering. I am myself a student. I am, in fact, I have got higher education experience of 21 years now. I'm teaching in higher education. But I am a student by heart. I continuously try to learn something new, and I was having, in fact, a lot of interest in artificial intelligence and machine learning. and I have tried to just, at that level, try to learn this as a student, and I'm just, um creating these with this little bit of a hard work which that goes into all of this, and on in making this possible with these videos which I am putting on a platform, and it is accessible freely to everybody so that they can get benefited out of it. And these these presentations and all, that it takes some effort. So I hope that this effort which I am putting, so that will be there will be some fruitful outcome of it, from it, especially to those viewers who are viewing this, this channel, and they will be getting benefited from there. So please provide your valuable feedback so that I can improve this. I'm a student myself. I consider myself always a student, and I will remain a student till I'm alive. And please provide your feedback, valuable feedback, so that it's going to be a learning for me as well. I will also learn. If you're having any suggestions to improve this particular platform, please provide that. Your critical suggestions will be very valuable for us. And do subscribe to the channel in case you feel that this is beneficial for you, and it is giving you some benefit. Please subscribe, and see you on the other side with one more very important concept, which will be on this hierarchical clustering, and then the unsupervised algorithms that we are going to discuss. Thank you so much once again for joining.